Now that we have our HTML and CSS all done, it's time to write a little JavaScript. So the first thing I'm going to do is create a map variable. There we go. And you can see the code is very straightforward. I created a variable called map, and to that I'm assigning an instance of the ol.map class. Now that constructor is taking a generic object as an argument, which contains several options. However, even though they're called options, these three items are required to render a map. First, we have the target, which references the container div, in our case, my map. Then we have a layers argument. Layers display the different data in your map. So you may have a base layer with terrain, followed by another layer with weather data, for example. Finally, we have the view. The view is responsible for things such as the map's extent, its resolution or zoom, and its rotation. Again, all three of those need to be present for the map to render. There are other options, and we'll talk some more about some of those other options in a later module. So the next thing we need to do is define what my layers and my view are. We'll begin with my layers. Again, a layer is simply a way to display a single data set in open layers. So here we have the variable myLayer, which is being assigned an instance of the ol.layer.tile class. Notice that we're not instantiating ol.layer directly. The layer class actually has three subclasses, which you work with directly. For this example, we'll be using the tile layer. This map is an example of using tiles. You can see that the map is broken up into individual segments, and when I pan, only those segments around the outside are redrawn. This reduces bandwidth and just improves overall flow. So coming back to our code again, we have the ol.layer.tile instance here, and we're passing an object, and in that object we have one option, which is source, and that is the value of new ol.source.osm class. In this case, OSM stands for OpenStreetMap. So what we're actually providing here is the OpenStreetMap built-in source from OpenLayers. Remember earlier how I mentioned that OpenLayers does a lot of the heavy work for you? This is a prime example of that. Instead of having to use the OpenStreetMap's API and figure out how to connect, it's already built into OpenLayers. All we have to do is set the source option of the ol.layer.tile class to this instance of ol.source.osm, and we're good to go. Now the name of the variable that we are passing to the layers option of the map is myLayers, plural, whereas the variable I've created up here is singular, myLayer. That's because you can pass one or more layers to the ol.map instance. For this example, we're just going to use a single layer. So in this case, myLayers is going to simply be an array with a single element of myLayer. The final piece of the puzzle is the view variable. And as you might have guessed, we're going to be instantiating another OpenLayers object. So here we have it, my view, and it's just an instance of the ol.view class. And we're passing in again a generic object with a couple of options. In this case, we have center and zoom. Now zoom has a value of 3, and you can probably pretty well infer that that's some numeric scale for zooming, where 1 is one particular zoom level all the way up to, let's say, 10, which is some other higher zoom level. Center, on the other hand, is referring to another variable which we have yet to define, center coords. Since the view is responsible for the extent of the map, then you can infer, and you'd be right, that center is the coordinates of the center of the map. And it's actually a 2-element array. So we'll go ahead and create that. Our center coords equals, and we're going to go for the middle of the US, which is roughly 95 west and 45 north. So there we go. We've created the map object, we've passed it a target, a layers, and a view. So now we should be ready to render. Let's have a look. So here's our map. The fact that we have a map, that's pretty cool. The fact that it's located in the wrong position, not so cool. It appears to be located over 0 latitude, 0 longitude. So let's take a look at the code and try and figure out why that is. We know that the center option of the view dictates where the map is centered. So let's go over to the OpenLayers documentation and see if we can figure out why this isn't working. So here we can see the ol.view class documentation. And the first option at the top here is center, which is of type ol.coordinate. So we'll check that out. And we see here that ol.coordinate is actually just an array representing any xy coordinate. So for example, as it shows there, 16, 48. So our syntax appears to be correct. So maybe there's a problem with the values that we're using. So the problem here is that center coordinates are in latitude and longitude. However, the map doesn't use latitude and longitude. The map is projected using EPSG 3857 or EPSG 900913, whichever one you want to use. Therefore, any reference to any coordinates have to be in the same projection as the map. Fortunately, OpenLayers can help us with this. So here I've defined a new variable, transcoords, and that is equal to the output of the ol.proj.transform function, which we pass in the center chords in latitude, longitude, and then the to and from projections. So the from projection would be EPSG 4326, i.e. latitude, longitude, and we want to translate it to EPSG 3857. So the output of this is a two-element array with an x and y value on the 2D grid of the EPSG 3857 projection. You might be wondering what those values look like, and so I've added this console.log transcoords line so we can dump it to the console and take a look. Now all that remains is to update center to use the transcoords instead of the center chords. We save and let's have a look. We refresh, and there we are over the United States of America. And you can see down here in the console the array. Notice that these values are much larger than a standard latitude and longitude. That's because these values are in meters. The Earth is roughly 40 million meters in circumference. And so you're going to have much larger values measuring everything in meters going around the Earth than you are breaking it up into 360 degrees. So why did the earlier map appear to be centered over the 0, 0 line? Well, that's because we passed in a value of -95 for the x value and a value of 45 for the y value. And given the scale of these axes, that's pretty close to 0. So let's take a look at our map and see what we did. We can pan, as expected. We can zoom in using the plus button, zoom out using the minus, or we can double click to zoom in. We can hold shift and drag to draw a bounding box and zoom in. Notice that as we zoom in, the map is updating with more and more detail. There are airports and street names. All this using free OpenStreetMaps data. You can also hold down Shift and Alt and rotate the map just by dragging. This little button at the top will allow you to return back to a north is up orientation. Down here, this little eye, if you click it, gives you an attribution. In this case, it lets us know that OpenStreetMap is powering our map for us. So we got all this out of just a few lines of code. So the next thing we need to do is transfer our code and newfound knowledge into the Catch the Hacker game. But before we do, we're going to take a quick closer look at the layers and the view objects.